The planet Earth isn't going to be habitable forever. If the human race is going to survive, one day we'll have to pack up our things and move to another planet. It sounds easy until you realize the vastness of space and even how big our solar system is. No matter where we're going in space, we need to travel fast, and not just at the speed of light either. We're talking about ludicrous speed. But some researchers have designed an impossible engine that violates the laws of physics, and another group of scientists are now saying a warp drive is possible. Is NASA really working on this technology, and what does the future hold for space travel? Consider this for a moment. Our closest neighbor, Alpha Centauri, is 4.367 light-years away. So even if we traveled in a ship at 100% light speed, it would still take you 4.367 years to get there. We could use rockets to get ourselves around in space, but the big problem with them is the amount of fuel we would need to carry to get anywhere. But even rockets have their limits, including how fast they can push a spacecraft. We're going to need something that can generate some serious thrust and be able to do so without carrying a large amount of fuel, because in space there are no gas stations. But there is an engine out there that reportedly can push a spacecraft around without the need for fuel. And this engine produces no exhaust either. You just plug it in, fire it up, and go. It's called the EM drive, or impossible engine, because it claims it can do the impossible. So how does this EM drive work? At first glance, it actually does look a bit like a rocket engine from the side. However, there are no openings in the device, and it works by bouncing around microwaves inside a closed chamber. That bouncing around of microwaves in the chamber is supposed to create a push, so to speak. This is a big deal, because all forms of rocketry require some conservation of momentum. In order to put a spacecraft in motion, you've got to push off something. For example, if you jump, your feet push off the ground. An airplane pushes off the air, and rockets use exhaust gas to push them and whatever they're carrying forward. But the EM drive doesn't push off anything. Basically, it's a container with microwaves bouncing around inside it, and it can supposedly move itself. Now you understand why this is called an impossible engine. The explanations for how this thing works goes past our current understanding of physics. Nobody really knows how it's supposed to work. It could turn out that our understanding of physics is broken, or perhaps the testing of this device will give us some brand new physics. The EM drive concept came to life in 2001, and there have been some research groups that claim they've measured a net force coming from their devices. However, what they're measuring is an incredibly small effect. So small, it couldn't move a piece of paper. So what we have after nearly 20 years is a bunch of experiments that haven't delivered something worth talking about, or any explanation of how they work. Some experts say that this drive will never work, and all projects will likely be a waste of time and money. It's possible that our understanding of physics or new physics not yet discovered could make this thing work. But there are other space engines out there that people said would never work, and they sprang to life. We're talking about the ion drive, something that was only thought possible in science fiction when this was first imagined. And when people first heard about a real ion drive, they also thought it would never produce enough power to move a small spacecraft. But the ion drive really does work. And in 2016, NASA awarded the California-based company Aerojet Rocketdyne $67 million to design, build, and test an advanced and super-efficient solar electric propulsion system, or SEP for short. They also call this drive a Hall effect thruster that uses propellant accelerated by an electric field. The ion drive works first by converting solar power to electricity. That electricity is used to accelerate ions out of a nozzle, which in turn generates thrust. It turns out that engineers have been developing SEP technology for more than half a century, and there are ion thrusters on multiple spacecraft, including NASA's Dawn probe, which is now orbiting the dwarf planet Ceres. There are plans to use the SEP drive for missions to Mars, but the issue with the ion drive is that it transfers a very small amount of momentum to the spacecraft. But while ion drives are slow, they're among the most fuel-efficient of all spacecraft propulsion methods. Right now, NASA is using a high-power electric propulsion system for the Lunar Gateway, an outpost that will orbit the Moon. In April 2021, NASA fired up the Iron Thruster system, which is about 30% more powerful than previous designs. But NASA started to look at another means of getting spacecraft quickly to their destination: nuclear pulse propulsion. Around the same time that nuclear jet engines were being developed for bombers, there's been some interest in using nuclear reactors to power spacecraft. One thing is that they can survive the cold, dark regions of space without requiring any sunlight, and they're also reliable. The Zeus reactor is designed to last 10 to 12 years, and it could propel spacecraft to other planets in less time. But there are some problems with this propulsion system too. Only fuel like highly enriched uranium can withstand a nuclear reactor's extremely high temperatures, and that doesn't make them safe to use. But there is another blow to this type of propulsion system, because the US recently prohibited the use of highly enriched uranium to propel objects in space if another safe means was possible. Right now, Russia is planning to launch a nuclear-powered spacecraft that will travel from the Moon, Venus, and then to Jupiter. Roscosmos said that its space tug will launch in 2030. The energy module that will power this spacecraft is called Zeus, basically a mobile nuclear power plant, and is designed to produce enough power to push heavy cargo through space. Right now, it would take more than 3 years to make a round-trip visit to Mars, but NASA figures that a nuclear-powered spacecraft can cut a year off that time. Now NASA wants to integrate a 10-kilowatt nuclear power plant with a lunar lander and put it on the Moon as early as 2027. The USA has never put a nuclear reactor into space, but Russia has put more than 30 reactors in space so far, and Zeus will use a 500-kilowatt nuclear reactor to jump from planet to planet. Advances in nuclear technology, such as nuclear fusion, may well change everything, but some say we're still far away, and propellant-powered rockets are the best we have at the moment. Propulsion of any spacecraft usually requires some sort of propellant, but there are other methods that use only the sun itself. Solar sails have been in development for many years now, but now that technology is advancing, spacecraft powered by the sun are fast becoming a reality. In 2019, SpaceX launched the LightSail 2 using the SpaceX Falcon Heavy. The $7 million LightSail 2 is 344 square feet in size and has sails made of tear-resistant mylar. When radiation pressure from the sun hits this material, it creates pressure which moves the spacecraft. So how fast can it go? That depends on how much sunlight is hitting the sails, and if the craft is far away from a star, it's going to move much slower. But what about warp drive technology? Just because you've heard that warp drive would be impossible to design and create doesn't mean it won't happen. In fact, scientists have just recently announced that a physical warp drive is now possible. Yes, seriously. In a new paper, researchers say that they've nailed down a physical model for a warp drive. Many have said the technology is impossible because it would require a huge amount of exotic negative forces. We all know the term warp drive comes from the famous science fiction series Star Trek. The Federation's faster-than-light-speed warp drive works by colliding matter and antimatter, which produces explosive power. But what about warp drives in reality? Our current understanding of the warp drive comes from the now iconic theoretical physicist named Miguel Alcubierre. This drive conforms to Einstein's theory of general relativity to achieve superluminal travel by a local expansion of space-time behind the spaceship and an opposite contraction in front of it. But the Alcubierre drive would need a ton of energy, probably more than what's available in the entire universe, in order to contract and twist space-time in front of it and create a bubble. If you were an astronaut inside that spaceship with the bubble around it, you wouldn't feel any acceleration. NASA has actually been trying to build a physical warp drive for the last decade, but hasn't made much progress yet. But this brings us to the new study. Scientists at the Advanced Propulsion Laboratory at Applied Physics unveiled the world's first model for a physical warp drive, where the existing model uses negative energy or exotic matter that doesn't exist or is impossible to generate with our current understanding of physics. This new concept uses floating bubbles of space-time, rather than floating ships in space-time. In fact, this new physical model uses almost none of the negative energy needed in the previous model and capitalizes on the idea that space-time bubbles can behave any way they want to. Alcubierre even endorsed this new model. However, this is just a concept for now, and the mass requirements needed are still enormous. But while a physical drive may not be a reality today, or even a century from now, with this exciting new model, warp speed travel is a lot closer than we previously thought. Do you think we'll see warp drive in our lifetime? Or do you think it'll be centuries away? Let us know what you think in the comments. Thanks for watching.